and then I'm just retrieving the coefficients for the linear boundary between the second and third class. I'm first separating versicolor and virginica, and then I'm plotting the curve which will separate the second and third class by putting a boundary equation. I'm just using this equation k plus x1 x2 into L is equal to 0. I'm just writing a mathematical function, and if you see, this boundary is exactly separating the classes, and few classes are missed out. Like if you just measure some classification metric, if you take this three classes, it's wrongly classified since it is coming in the other side of the boundary. So what I'm going to do is, whichever is coming in this side, it will be classified as this, and it will be classified as some other class. But again, here I'm having setosa. I need to draw a boundary between these two again. That is what I'm doing next. So I'm just retrieving the coefficient for the linear boundary between first two class, plotting the curve which separates the first two class. So from this, it clearly classifies setosa, versicolor, and virginica. And again, that is a linear discriminant classifier. And you can write a quadratic classification also. That is, here if I put a curve, it will be better rather than drawing a line. So for that, I'm just fitting a quadratic line. And initially, I have plotted linear boundaries. Now I'm just removing that. See here in this, if I just put delete of H2, delete of H3, just deleting. See, it's very, very interesting. You can just try each and everything. MATLAB is very user-friendly. And you are just fitting the quadratic equation, and so many inbuilt functions are available. We're just going to take this equation. We are using linear, we are having a constant, and we are having a quadratic function. I'm just writing the function and applying it. And then I'm retrieving the coefficients. See here, this is how the quadratic equations graph will be coming. And if I plot the second and third boundary, I'll be getting this. So it's clearly classifying first two, and in between 2 and 3, we have drawn a quadratic equation. So this is a simple example for image classification. So actually, it's, as I told you, classification is your high-level processing. So you need to start from simple pre-processing technique. You apply a different enhancement technique, and if your image is affected by noise, you just apply some noise removal technique by filter. We are having so many filters available: median filter, mean filter, and in median filter, wide varieties of median filters are available. And you can go for frequency domain filtering, means you can go for low pass, high pass, band pass filtering as per your application. And then next level processing is, if you want to segment certain portion, you just go for segmentation application. And then whatever features you want to extract as per your application, you extract the important features, and from the extracted feature, you try to classify to different image. That is your high level processing. Again, the problem is not just over with that. As per your application, if you want to do certain analysis out of the classified output, you can do the analysis. So it's very, very important application. As I told you, like now we are having so many different types of neural networks have been established. Like it's just like humans. It's thinking, we are making the machine to think on its own, and it will do different things whatever we want to do. Okay, so with the small introduction to classification, I'll close today's session.